for those of you who are following this remotely, which is everybody, the chairs are just gathering people, and we'll soon be starting the TSVWG meeting. This will be the second of the two meetings, so the agenda's the second set of information in the documents area. Okay, can I confirm with people whether we have a note taker? And somebody's watching Jab. Do we have a note taker? Do we have a volunteer for a note taker?
Jake is in the queue. That might be a volunteer.
Feel free to volunteer.
Sure, I was raising my hand to volunteer. I can do it. I'd be happy to have assistance. I see Andrew offering in the chat. So yeah, please. Great, and thanks, Brian, also.
I just pasted the agenda into the notepad.
So for those that you are following the notepad, can you look to the end of the notepad, because the session notes are going to be taken after the current items. Okay, they're now being entered. So that's great. So we have a note taker and a few backups. That's great.
So a clarification there. The link that I saw on the note-taking tool from inside the Meet Echo here is pointing me to something that that is new for this session, right? So that's Notes IETF 109 TSV2, which I'll put the link here just to clarify in the chat. And so
that's interesting, because the link I followed off the agenda page. Get the right one or get the wrong one? No, my mistake, perhaps.
Okay, I think there's opportunity to get this wrong in the agenda, so I might get it wrong as well.
Right. So there are separate strings for the Meet Echo session, because it's like 2 sessions is 2 sessions, but the agenda page actually links back to the same for the 2 sessions thing. So that's actually probably something we should talk to Meet Echo about for the second time, but let's use the link that I posted, so they're all in the same place, just to keep you all from having to merge things.
okay, I will do that. Thank you.
Asked is to like put a link to the second one and the one you're not using, so people can fall back to it if they get to the wrong one.
I will do that.
Oh, very helpful.
Okay, Bob, I've just uploaded your slides, so I think we have all of the meeting materials posted now.
Where are the notes for the first meeting? So I can just quickly look at them.
They're in the same page as we're taking the notes in the second meeting. Just scroll upward.
No, they're not. There's nothing in the current meeting page in the proceedings. Go
If you
recheck.
follow the link that Brian pasted, it's all there.
Okay.
All right, should we get started here?
I think we can get started.
Yeah, so I think we have already spent time wrestling with tools here. So I think we probably should just jump into the agenda. So I think today we have Greg on the operational guidance, then Bob on the other L4S drafts. And if there's any time left, there's some L4S and 5G work that Ingemar will discuss. So if there's nothing else or any agenda bashing people want to do, I think we'll go straight to Greg.
Looks good to me. I have Bob's slides, so I'll put those in the notes as well.
Okay, are you able to hear me? Test 1, 2, test 1, 2.
Yes, we can.
Yeah, I hear you, Doug.
All right, thank you.
I'm trying to pull your charts up.
Okay, so this first topic is to discuss this work in progress draft title operational guidance for deployment of L4S in the internet. This is an individual draft that I agreed to put together as an editor and in collaboration with several others from the working group, folding in suggestions that had been made via email on the mailing list over the past several months. You go on to the next slide. So although the title of the draft may make it sound like it's covering more territory than it is, I want to make it clear here that the scope actually of the draft is specific to a single issue, and that is the issue of single queue RFC 3168 bottleneck links, and some issues that that need to be dealt with in that case. And in particular, it provides guidance for operators of hosts that would like to utilize L4S, and guidance to operators of networks, in particular networks that have deployed single queue RFC 3168 bottleneck links, and then recommendations to researchers as well, and how to things that they could look at and try to understand the scope of the issue and any severity metrics that could be derived from that. So all the general requirements for L4S, definition of the L4S experiment itself, and other operational guidance for L4S hosts and networks can all be found in the L4S drafts themselves. So the architecture draft, dual queue coupled AQM draft, and the ECN L4S ID draft. There was a comment recently on the mailing list from Jake and Pete Heist that perhaps this draft should also mention FQ bottleneck links that implement RFC 3168. I think the next slide talks a little bit about, well, I'll come back to that, get to that point on the next slide. Move on. So just to summarize, the situations where coexistence of L4S and classic traffic have been discussed in the mailing list. We group the different network bottleneck types in these 6 categories based on the active queue management technology that exists in that bottleneck and the scheduler that exists at that bottleneck. So the AQMs could be an L4S, ECN AQM, could be a classic ECN AQM, could be just an AQM that does packet drop, so no ECN at all, or it could even be no AQM at all and just tail drop. And the scheduling could be dual queue or FQ or a single queue FIFO. In all of these cases, L4S traffic and classic traffic coexist well, except for the one in red where there's a problem that's been identified where classic flows will receive less throughput than L4S flows when they are coexisting in a bottleneck that is a single queue and classic ECN. And so that's the focus of the draft. There is an asterisk on the FQ classic ECN case, and this is getting back to Jake and Pete's comment that there are scenarios in an FQ classic ECN bottleneck where we don't see fairness being enforced by FQ. One of those is a case where you've got mixed traffic in tunnels that are going through the FQ. FQ is known to not provide fairness for the flows that are inside tunnels. And in this case, if you have a tunnel that has a mix of classic and L4S traffic, there's a further unfairness between the flows that are within the tunnel. Also, there's a potential in some FQ implementations for hash collisions to result in multiple flows sharing a single queue. And so in those relatively rare cases where you'd have multiple long-running flows that are hashed into the same queue, and those multiple long-running flows are mixed L4S and classic, then you could see some unfairness there as well. I think most of the bottleneck links that implement FQ today run a more advanced version of FQ that eliminates a lot of that issue around hash collisions. Okay, next slide.
We have a comment from Sebastian.
Something? Can I? Do you hear me?
Yes, please go ahead.
Okay, so this looks fine and very systematic, except that the first row in this table is pretty much under discussion. So it says dual queue coupled AKM provides reasonable fairness across a range of conditions, which is true, I admit that. The problem is whether the range of tested conditions actually is sufficiently broad to allow extrapolation onto the wider internet. And I do not believe that this is currently true. That's just the point I wanted to make.
Okay, thanks. Thanks. So a little bit more detail on this specific issue of the classic ECN bottleneck. So RFC 3168 is the definition of classic ECN, where in AQM CE marks are applied to ECT0 and ECT1 packets instead of drop. And L4S, which uses ECT1, responds differently to those CE marks compared to classic senders, which use ECT0. And specifically, the L4S flows effectively aim for a higher CE marking rate than classic flows do. And so when you've got a mix of the two flow types sharing a single queue RFC 3168 bottleneck, the L4S flows will outperform the classic flows. And so this really affects when you have multiple long-running capacity-seeking flows, where this phenomenon occurs. Appears to be worse in situations with moderate BDP levels, so on the order of 100 to 150 packets, give or take, seems to be where the problem is most pronounced. So less so in low BDP connections or in high BDP connections. So low data rate connections, not as big of an issue. And appears that potentially it's for the high BDP case, potentially when Cubic is operating in its cubic mode, maybe that's the reason why we see less impact at the high BDP case. But in the cases where the impact is at its worst, it's been shown to result in more than 10-to-1 flow rate ratio. And there's an example of some of the data that's been shown on that. There's a number of experiments have been done over the past year or more on that, but you can see figure 1 in that link, for example. Okay, next slide.
I see Sebastian, you. I don't know if there's something more you want to share, or if you're still in there from the last chart. Okay.
Next slide. Yeah. So the draft has again these sections on guidance for the different audiences. So the operator of an L4S host breaks down the host into two categories. So one that would be deployed in a constrained, where there's a constrained set of networks or clients that it's serving, where there are opportunities for coordination and pre-launch testing across that constrained set of networks or clients. And so the draft talks about what some of those options are. And as I mentioned, this is a work in progress draft. So there are some to-dos left in this section. Certainly would invite input from the working group on more details that can be added in these sections as well as others. So in particular, one thing that seems to be potentially useful in the case of the CDN or ISP servers is to do some pre-launch testing to assess the presence or absence of these bottlenecks. And there it'd be nice to have some specific tests called out, or specific requirements around those tests in the draft to give guidance for those who might be interested in deploying hosts. And the second kind of sub-bullet under section 3.1 is in-band detection monitoring. So the L4S ID draft has some mandatory features that hosts need to support to facilitate this, to attempt to detect RFC 3168 in the bottleneck. And then the server could fall back in real time. So when it detects the potential presence of RFC 3168, it immediately discontinues the L4S congestion response and utilizes the classic congestion response. An alternative would be to flag that path of that host client as being potentially behind a 3168 bottleneck, and then discontinue using L4S for future connections to that host. And the second subsection in section 3 is other hosts that are serving a much wider set of networks or clients, where that pre-launch testing may be not feasible. Still, the in-band methods apply, and either a real-time or non-real-time response for those. Real-time might be a little bit more feasible there. Also could be some per destination path testing that could take place in addition to the in-band detection monitoring, and the draft has a placeholder for specific tests there. And again, feedback or input would be helpful to flesh out that as well as the other components of this section.
Yeah, Greg, where do you expect the code that implements those tests to reside? Is that residing in the protocol being used by the servers involved and other hosts, or do you expect separate test functionality?
Well, I think it depends. So the pre-launch testing seems to me to be separate testing code that would be provided on a L4S host that could be used to detect whether RFC 3168 exists or not. Certainly, the in-band detection monitoring is utilizing features that are already required in L4S hosts by the L4S ID draft. The response mechanism, whether it's fallback or real-time response, certainly would have to be a feature supported by the L4S implementation in the sender. Non-real-time response would presumably be somewhat different code, but more operational management code that could control whether or not L4S is enabled on a per host basis. So I think it's a mix, but the draft could certainly add some detail on that.
Okay, just please make sure that answer is reflected in the draft.
Okay. So there's someone in the Andrew's in the queue.
So I was wondering, as a follow-up to David's question, on what kind of granularity you expect this to be done, as in per what destination prefix per host, or what?
That's a good question. So it probably depends a bit on the network. So one scenario that has been highlighted on the mailing list is a residential ISP where the individual customer, so a single IP address, may have an implementation of a single queue RF6138 bottleneck in their network. And so the results of this testing could be different on an IP address by IP address basis. That may not be true in all scenarios, but certainly could be that granularity. Okay. Any other comments on that? All right, next slide then. The next section, the draft talks about recommendations for an operator who has deployed single queue RFC 3168 bottlenecks. It provides currently a list of potential options for configuring that bottleneck to, or those bottlenecks to work better with L4S traffic. I won't go through all these in detail on the call, but the first one, there was a question on the mailing list whether routers are able to actually support that. I think certainly it's well known that software routers can do that, but I guess the question would be in hardware routers, are there restrictions that would prevent the differential treatment between ECT0 and ECT1? So that in that case here, it's effectively treating ECT1 as not ECT and only doing congestion experience marking on ECT0 packets. For all of these, I think the kind of open question to network gear vendors and operators as to how feasible are all of these? Are there any downsides to any one of these? Are there other options that have not been identified so far that could be added to this section? And further details, I guess, on configuration of these different approaches would be helpful. Okay, yeah, we can. Corey?
Okay, I just wondered if anybody who was joining the meeting had any eyes which might help us from the understanding of particular operated routers that they're using, or maybe they're a vendor. Does anybody come from the vendor community who wants to kind of comment quickly on that list that we just had up?
Go ahead.
Routers exist that can do 4.1, treat ECT1 as not ECT. Jonathan pointed out in the chat that it's formally contrary to RFC 3168. I don't think the feature is particularly common, or the ability is particularly common, but it does exist in some routers.
Thank you. That was Andrew McGregor, yeah?
Was.
Yes.
Well, anybody else from the operator community?
Can I just pick up Andrew's point about formally being contrary to 3168? I don't think it is, because it's not saying you don't change ECT1 to not ECT. You just treat it as not ECT. So you're effectively being a non-ECN router for the ECT1 code point.
Bob, while you're on the line, wasn't this something in PCN anyway? So we have had specs that have played with ECT1 in the IETF in a different context.
That is true, yeah. And on the standards track, in fact.
Oh yeah, I shouldn't say playing, yeah, a standards track.
Yeah.
Okay, I wasn't meaning to hold up the talk. I was just hoping to start this discussion with people who had inside knowledge about what products might actually offer. I'll leave them on.
I think it's also been suggested that the working group could consider formally deprecating treating ECT1 identically to ECT0. I think, as has been pointed out, it's not required to be treated the same, but it could be formally deprecated, and that might nudge things along towards implementing 4.1. Okay, next slide. Oh, a couple of people in the queue. Bob, go ahead.
Oh, sorry. I'm not in the queue.
Okay, Jake.
I thought 8311 did that. and placed some requirements on it. Is that not correct? That is deprecated the treatment of ECT1 as necessarily the same as ECT0. I thought that's already like released as standards track.
My recollection is it opens the door to alternative treatments as long as they are documented in an experimental RFC, but doesn't.
I see the distinction. You're saying
treating them as.
You're saying
this is slightly different. And I think goes back to 3168, which in particular, 3168 allows drop of ECT marked traffic and endpoints that apply to 3168 have to be prepared to deal with drops because somebody got backed up and couldn't mark, had to drop. And so if you configure this, you're still compatible with 3168 as far as I can tell.
Okay. All right. I'm short on time here. So section 5 in the draft, role for researchers. Pretty lightweight text in this section so far. So certainly would appreciate input from researchers on things we could add to the section. And Ruger on the list pointing out as well that it would be nice to have some specific test requirements in this section and not just the fairly high-level statements here. But we do have at least the high-level statements of a couple of items that researchers could look at. Obviously, detecting 3168 through measurement campaigns would be an interesting step. There's been some attempt at that in the past, but more useful. Also, out-of-band measurement of L4S versus classic performance might be something that could be done as well. And then not in the draft yet, but something is pointed out off list to me, research looking at how often do you have multiple long-running flows coinciding within a bottleneck link? And how often does it happen, and help and can assess the scope of the issue. Looks like your mic is still on, Bob. I don't know if you're aware of that. Next slide then. So there's some additional mailing list comments recently, last few days. Sebastian had a comment to reword the phrase more precise flow balance in reference to dual queue. Jonathan Morden pointed out that if the working group had gone a different path, then we wouldn't have to write this draft. And then Jake had a couple of other comments around adding some references that help illustrate the unfairness issue. And then raised the question, the draft is currently listed as an informational draft, raised the question of whether that's the appropriate categorization or should it be listed as experimental. And so that can be open for discussion. So next slide. So last slide. I think this is time for the working group to consider whether this is something we adopt. And I think, as I said, I've been the editor and folding in comments from and text provided from others. There have been several who have contributed text, but I would hope that with adoption, we would bring a commitment from the working group to flesh this out and provide a full list of what we're aware of in terms of guidance for making L4S work well with in the presence of 3168 bottlenecks. So I'll hand it back to the chairs.
Yeah, I think starting an adoption call on the mailing list is probably a good idea, but I think we'd like to open the floor to hear some other people's thoughts, but I think because this is something that came about as a mitigation to some of the comments and concerns people had when we decided to make the ECT1 decision at the interim meeting, I think this is probably a good thing to adopt myself. So I think Jonathan's in the queue, so please go ahead, Jonathan.
So I'd just like to clarify a very brief summary of what this draft is trying to do, which is basically ensure that any network that carries L4S traffic is specially prepared for it, and that L4S traffic does not escape such a network. Is that correct?
I think that's overstating it. As I indicated in the first few slides, there are known to exist these 3168 single queue bottleneck implementations. What's not known is the prevalence of them, believed to be rare. At least studies so far have not shown them to be widely deployed in bottleneck locations. And again, as I discussed earlier, the impact of them existing is not catastrophic. It's not a major issue in a lot of cases, but it's only in the case of long-running flows, sharing those bottlenecks with a moderate BDP levels where the result is something that we want to track and avoid if possible. So I wouldn't say it has anything to do with making networks in general prepared for L4S. It's really just this specific scenario.
So when it comes to these long-running flows sharing a single queue, does that take into account the possibility of tunnels encountering an AQM, even if that AQM is flow aware? It will treat the tunnel as a single flow, put it into a single queue, apply a single AQM instance to it.
Yeah, as I mentioned earlier, that the asterisk on that earlier slide. So flow queuing bottlenecks group tunnel traffic into a single queue, and so they don't provide fairness for tunnel traffic or flows that are within a tunnel. That's a known issue with FQ systems. And on top of that, if the mix of flows within that tunnel contains both L4S and classic, then the entire tunnel is clearly only seeing a single CE marking. Well, at least existing FQ implementations, that tunnel traffic would see a single CE marking probability, and you'd see further unfairness within the flows inside the tunnel. That's true. It's been discussed that it's fairly straightforward for FQ implementations to support the L4S marking thresholds, so it's not a problem with FQ in general, but yes, in the case of tunnel traffic over an FQ bottleneck, then there's unfairness that can happen there as well.
Mm-hmm.
I think we're running short of time, so I think we probably need to move to Stuart and Janet's comments as quickly as we can.
Yeah, I'd just like to mention that in risk analysis, we need to consider both the prevalence and the severity. So we should also have a discussion about the severity at some point.
Yeah, I touched on that in the earlier slides, but that's certainly something to be studied further. Thanks. Stuart?
Hi. Yeah, I just wanted to comment on the previous point. As I think many people know, we enabled ECN in Apple clients several years back, so they would negotiate end-to-end ECN with the majority of Linux servers out there. I wish we had the problem today of deployed legacy ECN routers that were doing smart queuing instead of tail drop. The sad reality is that from the data we've collected from 1 billion iPhones around the world, the prevalence of ECN marking routers is 0% to many decimal places. So it would be nice if we had that legacy problem to deal with, but the fact is we don't.
Thank you, Stuart. That's definitely good feedback. Help understand the scope of this issue and or maybe lack thereof. All right, Jana?
Hi. Stuart, I love the 0% to many decimal places, by the way. I'd love to know. The thing I wanted to say about this draft is that I think it's the general, it makes a lot of sense to have an operational guidance draft in the working group for this. I think the questions that are being raised and addressed in this draft are very useful, and I think this ought to be adopted. I've taken a look at the draft. I'll have to admit to not having read it carefully. It seems very thin, but I suspect that can be resolved as we get into as it gets into the working group. I would definitely encourage adoption of this. The one thing I would also suggest is maybe to articulate a little bit more articulate the goal as not to promote fairness, but to avoid unfairness. I think there is a difference between the two. But again, that is a nit. I don't want to spend too much time on it here.
Okay, thank you. Good feedback. Jake?
Yeah, so I did a presentation at MapRG, the interim MapRG. I think it was just after last IETF, and it was a joint interim with that other conference, right? Yeah, and they so we did not see 0%. There were several networks in which we saw non-zero percentage deployment of ECN when we looked according to ASN. So I would be very interested, Stuart, if you get a chance to. I don't know if you're planning on publishing the data that you see, but not only did we see non-0% in a number of networks, but we saw growth in adoption over the last year. So I just wanted to mention that although I agree the deployment is relatively low when you look in the aggregate, it was only 0% down to 2 decimal places for us overall. And I think we are getting probably a different data set than what iPhone would see in general, but we did have some 0% to many decimal places was not our observation. So it might be good to sort of see if we can link those up a little better and maybe even get an ongoing refresh of that perhaps. Thanks. I just wanted to point that out in case anybody hadn't seen it. Thank you.
Yeah, thanks for that, Jake. If you have newer data than the data we collected a year or two ago, that would be interesting. The one suggestion I would have is when we first collected data, we were seeing some plausible amount of ECN marking in Argentina, notably, and in France. And it led us to a false sense of optimism at the start. And when we dug into a little bit deeper, it turned out to be bogus. It wasn't actual working smart queuing with ECN. It was, as far as we could tell, it was just bugs. So
Yeah.
if you have evidence of actual working ECN, that's very interesting, because
thank you. We did note that when we started our project, and we were looking for it also, and did fail to replicate that. I think I reported that in the presentation I did. But nonetheless, there were other networks where by country, it was hard to find anything with that remotely approached some of the numbers you reported in the initial stuff, and I understand that was found to be bugs. I think that's also been reported and maybe mentioned during that talk. But they're looking at individual networks. There are some that do appear to be doing real ECN traffic. Yeah. Thanks.
Bob?
Yeah, just just to make sure everyone's caught up on this as well. Jake's data was important, but then there's also the question of, was that single queue or FQ? Because obviously in the last few years, FQ Coddle has been deployed with ECN support, and so I would have expected to see some of that, and I'm assuming that's what Jake was finding, but we obviously now don't know without even more difficult tests to distinguish between an FQ producing CE and a single queue, because the FQ obviously does the scheduling itself and isn't going to allow this domination of one flow by another.
Okay, yeah, thanks, Bob. I see no one else in the queue, so I guess I hand it back to the chairs.
Yeah, and I think this has been useful discussion. I think we're going to plan to take a adoption call to the mailing list.
One quick reflective discussion from the chat. We're going to run over 1 hour into the break. Sebastian suggested that we take no more than 25 minutes of the break, which seems like a reasonable suggestion.
Can I ask, Wes, that we also check how many people have read the adoption draft, this or the previous version, and therefore get some view of the number of people who've been exposed to this?
Sure.
Do we know how to press these buttons? I don't.
I think I just posted a question. Operator guidance draft, have you read it? It looks like a decent threshold of people have read it.
So click on the bar chart and tick raise your hand if you have read it, or do not raise your hand if you have not read it. And we'll collect that as we go into the next talk so that we can run this adoption call later on the list. Back to you, Wes.
And Bob, are you planning to project your charts?
I would rather you did, to be honest, but I suppose I could, whatever. No, you do it.
Okay.
Is that okay?
It'll take a minute.
Okay. I only say that because I've not done it before, so it will take me a minute as well to work out how to do it. I guess I could just start by saying that what the next talk is going to be before we get the title slide It's a status update on L4S and the three main L4S drafts, other than the one Greg has just been talking about. That's the architecture draft, the L4S ID, and the dual queue coupled AQM. Right, that's fairly small on my screen.
Well, can I jump in just for 1 second?
Yep.
While you're getting the screen sorted, I want to summarise the results of the poll that we just ran.
Please do, yeah.
Yeah, there were 15 people said that they'd read one of the operational drafts, one of the 2 revisions, and there were 19 people who said that they hadn't, presumably intended to. So a reasonable number of people have read this, and that's useful input to our process as chairs. Thanks ever so much. That poll's closed. Back to you, Bob.
Okay, yeah, actually, I don't know. Was that meant to be a precursor to a working group adoption, or what's going to happen with that?
Yes, that's a precursor to a group adoption. We'll handle that in the list.
Okay, good. Yeah. Right.
+1, yeah.
Okay, so they have the 3 drafts with their revision numbers, and next slide, please. One slide recap of what L4S is and how it's motivated. It's motivated as desire for ultra low queuing delay for all internet applications, so that you don't have the problem of the management problem of having some favored over others, and the key idea is getting smaller saw teeth to respond to congestion, so that you don't have the compromise between low queuing delay and poor utilization. So you can keep your get your AQM right tight, and you also get then scalable throughput, which is the S part of the L4S, which otherwise that has been known since early work in the 1990s, which Sally Floyd published as an RFC 3649, I think. You get longer and longer time between each sawtooth as you try and get faster, and you get less tight control. Next. All right, I'll try and speed up. The just a bit of news on various implementation things been going on since the last time we gave a status update, which was April, I believe, maybe July, I can't remember. The low latency DOCSIS working group has been continuing doing interop testing. Currently 3 independent implementations, 2 cable modems, 1 CMTS, and 2 implementations now completely pass all the functional tests. There was I know before I left Cable Labs, there was a large set of conformance tests and functional tests that were defined against the spec. Next one, this work hasn't started yet, but the only new news is that it's got a date for when it's planned to start, and that's the data plane development kit. That's the open source libraries for virtualization for a variety of CPU architectures, and that's planned for dual queue coupled AQM implementation in Q1 next year. And then there's a lot of publications come out of NS3, sorry, by publications I mean published source, out of the NS3 efforts. There's the simulation model of low latency DOCSIS itself, which was used by the low latency DOCSIS working group to test everything, and that's in the NS3 App Store, and that link takes you to it off the slides, and it includes not only the dual queue coupled AQM but also low latency DOCSIS queue protection, which I think will be useful news to some people who've been wanting a form of queue protection to test things against. And there's also a link to Cable Labs press release about that, so you can get a quick feel for what's in that. That was released in September. Then it also Tom Henderson pointed out, Tom was largely pulling all that stuff above together. Then he's also pointed out that L4S support has been added to CODL and FQ CODL models in NS3, and it's about to be released. It's been added and about to be released in FQ Pi and FQ Cobalt in their models in NS3, and it's already in the Linux FQ CODL, and that adds as well. They add to the IETF dual queue coupled AQM, meaning the one that's in the IETF draft, the sort of reference pseudocode. The code for that is also modeled in NS3 and has been for some time. Right, next. Right, just want a quick heads up. We have a ICCRG session on Friday, 0500 UTC, 1400 in Bangkok time, and I think that's right. No, midday, 1200 Bangkok time, and I'll give a quick outline of what's going to happen. We have a congestion control that gives really low latency over a range of conditions, as in that paper, reasonable RTTs and link rates, but pieces of it are still missing. That's absolutely obvious. So it's easy to think up conditions where it doesn't work well and show that. And we admit progress has been slow, covering up all those holes and fixing it all. So, as we've said many times, we being the core team, the design team working on L4S, we're primarily for network companies and being network operators or vendors for networks. And we've got a bit of a background in congestion control over the years, but we're not the guys that will produce this. So, we're having to do it in spare time because it's not funded by our companies and so on. So we want to generate interest in the problem and the potential again. And we thought if we explain the interesting things that we've had to do in DC-TCP to get it to meet all these Prague requirements and work over the internet and talk about what we've learned, we might generate some interest and get a bit of a buzz around this. But at the end of the talk, we want to start a conversation about what is needed to get that buzz going again. Because after the initial buzz, we imagined that this was a good, had enough potential that people would want to work on this. We imagined a different way of building congestion control, if you like, whereas mostly what a congestion control has been given as a blob to the community by researchers. And we were thinking it'd be great to have something where different components were brought in by different groups as more open source project, and that didn't happen, and that's probably our fault, nearly certainly our fault as the core team. Just we didn't do it right, didn't make it open enough at the start. But now something worse has happened. We've sort of got a toxic code point war that's it's good to have a red team, to be picking holes in everything, but it's now getting to the point where it's I think being a bit more destructive, in that there are problems that aren't really anything to do with L4S congestion controls in particular that you could pick up in other congestion controls that are being pulled out for that. And so I think it overshadows the potential of any congestion control using high fidelity signaling, where we're risking losing sight of the potential of this. So we want a conversation about what a relaunch would need to look like for you to want to get involved, and we're looking for constructive views, but I'm not asking for that now. I'm just giving a heads up.
Okay,
Hi, Bob.
Go for it, Martin.
Bob, so yeah, there's there was some confusion about the deadline for this meeting, and that's not your fault. However, I and many other people are not going to be able to stretch this until 55 past. Is there any way you can bring forward like the key takeaways, and then for people who are interested, they'd be welcome to stick around for your full presentation? Yeah. I'm sorry for that. I know this is unfortunate.
Yeah, it's actually the next slide. I think I was going to say, if you want to hear the whole talk in the next slide, then you can go if you want. So all three drafts, the rest of the talk is about the L4S drafts, because we've been putting a lot of work into them to get them finished and ready for working group last call. In our humble opinion, that stands for, or it's an anagram of Ohio. The only bit left really is what the status of this L4S Ops draft is. It's an individual draft, so we didn't refer to it yet. So we need to put in a reference to that, but otherwise we're done, and describe it a bit in the L4S ID. But otherwise, the three drafts, there's the L4S architecture. I had 2 revs since the last status update. And I guess the main change, I mean, there's been some very significant change in that, and I will go through them. But top level, really, it's put FQ up there with dual queue as sort of alternatives in the architecture. It's no longer the dual queue is no longer the architecture. It's FQ as well, and the other L4S ID draft. There's been a lot of changes in that one, mainly, I mean, a lot of clarity changes, but there's also been a number of normative text changes based on conversations on the list, where we've been tweaking the wording, if you like, and some new stuff about smoothing signals, pacing, to make them requirements, because that draft is primarily a draft about how to write a congestion control draft, or how to write a draft about network equipment, and it's giving the requirements as to what has to be in that draft. So there's some shoulds and musts on what has to be in those things about pacing and stuff. And finally, the dual queue coupled AQM, that's very stable. I couldn't find anything to change in that, just some editorial stuff. So that's the top level for Martin, if you want to go now.
Well, Bob, I think that might be a good point just to pause for a moment and see if people have questions, because you'll have time to present the rest later, but it'd be more important to take questions if people have observations or questions on this from the room. Would anyone like to join our queue? Go ahead.
Thank you. Should I start?
Go.
Okay, thank you. Well, at a high level, Bob, I don't know that we need to go over all the L4S drafts again, but I want to ask, what is the intent here ultimately? Are we asking whether we should go to last call? Are there any major issues pending? To the extent that I've seen, my understanding is that the biggest issue I've seen, and forgive me if I've not seen all the issues, is the competition with classic EQN at 5.4 queues. And is that the biggest issue that's pending? Because I'd like to speak to that if that is the biggest issue that's pending.
I guess that and the point I've just made about our congestion control is not up to speed with the aspirations in this draft. But one of the questions at the end is the intent that is part of the experiment, rather than
right. So maybe I'll just take a minute to speak to both of those points, because I think my point ought to cover them both. At a high level, I feel feel like this is ready for an experiment. I absolutely think that we should outline
precisely what the outcomes of the experiment ought to be, meaning that what are we measuring, what are we looking to see. But it absolutely seems like we are ready to launch this experiment. Something that Stuart said earlier is very, I think, it's an important point to note here. If the concern about competition with classic ECN is a concern, I might argue that that only becomes a real concern or a reality if L4S becomes very successful. I would like that to happen. I would like L4S to become successful, and I would like it to become a problem for the non-existent classic ECN. So if the world we are talking about is potentially that we could make this, get this out the door, try and deploy L4S, then let's do it. I don't know that we need to wait for much else at this point.
So Colin Perkins in Java says +1. Are there more comments apart from John's?
I was going to add to John's comment that I think John's comment suggests that path to successful working group last call on the main L4S drafts runs through solidification of the L4S operations draft. That's where the 3168 issue gets settled.
Are you taking that as a comment that we're not ready, David?
I'm not sure. I think as part of working group last call, working group has to judge whether there's a reasonable approach to dealing with 3168.
Yeah, I concur with that, and I think that is. I mean, just so to clarify for anybody who's watching this or listening remotely, the working group last call doesn't confirm the document. The working group last call gives people a last call for comments on it, where we have to in detail check that things are right. And the document could be frozen after that, or the document could be published, or the document could have certain pieces of work identified that need to be done. So, or indeed it could be dropped. The working group last call is a call for comments. We're seeing several things in the Jabber. Does anybody want to speak? We can take notes from the Jabber. I see two people saying that not ready. Go ahead.
I've taken some notes from the Jabber, recorded several +1s, and I believe the Jana's statement, and also some several notes saying not ready. They'll be there in the notes as best I can capture them.
Yeah, something significant from John Morton. He said, I'll read it exactly. I think working group last call at least has to wait for L4S ops to be completed. So that's a personal statement that the ops draft should be completed. Does anybody want to speak to that one?
To that, for no particular reason, but because I'm here in the queue. I don't think that we need to wait for the ops drafts. I mean, I think the ops drafts are useful. It's a brand new one, and I think that putting that on the critical path rushes the draft. I think it's worth spending some time getting that ironed out, just in terms of getting the text right and everything else. But I still don't understand why that needs to be on the critical path for getting these to experimental status. If people know how to deploy this stuff, then they can do it.
Any more thoughts?
So I'm in the queue after Jana, but I see Colin and Jana still ahead of me, or should I just speak? I guess. I guess I will. So the you know, the tests that Jonathan and Pete have published lately do show some bad problems. I guess the claim is that this is, as I understand it, is essentially sufficient to call the L4S experiment likely to fail. So I'm not sure if the intent is to sort of just fix that after seeing the experiments, and I'm not sure why that wouldn't happen in lab before moving it forward. But I guess the sentiment here seems to be, let's get this rolled out so that people can try it or something. I think there's already an implementation people can try, so I'm a little confused what the holdup is on running an experiment just in terms of gathering data. I'm not sure how that relates exactly to the last call or not. Like, to me so far, what's been demonstrated kind of just looks like probably a bad idea, but there might be fixes for it that could be in the works. And I guess the idea is to generate interest enough to get them actually fixed. You know, that's just my sort of take on the experiments I've seen so far. But yeah, in terms of, I guess the goal here is to get wider operational experiment, and that's waiting on a draft. I'm a little just confused on an RFC rather than on a draft, and I'm a little confused on how that even relates exactly. So I don't know who wants to speak to that, but.
So I'm not sure who's running the queue, but I guess I may be next. I don't think we need to wait for the ops draft here. I'm confused as to why we're not just proceeding with this already. The problems we've seen identified seem very minor and unlikely to be a practical issue. So I don't quite understand why we're not proceeding with the experiment. So yes, I would encourage us to move forward with this.
Okay, so I guess it's my turn, and I will echo what some people said on the Slack that on the chat, that a little active queue management telling us who's next would be helpful from the chairs. So I'm sort of struggling to know what the experiment actually is, right? So there's a bunch of specs that talk about, queuing scheme and all that. That's great, but what's the experiment? And I think I tried to say this in email. So at least in my mind, this TCP variant that would do something clever with whatever we put into the network is sort of an intrinsic part of the experiment, because how else are you going to evaluate something? And that part I don't really see described, right? So I'm probably convinced that what we have in the draft is sort of described well enough that you can implement a queuing scheme like this, but I don't quite know. I don't know what we're going to experiment with. What's the outcome, and what data do we want out of the experiment to know whether we succeeded or not? That's the part I'm struggling with.
Yes, so I think the experiment is, so I think problems that have been detected about dual queue actually make certain assumptions about deployments. So part of the experiment is actually to figure out if these deployments do exist and are a problem, because we assume that it's not the case. So, that's something we can figure out from a larger scale experimentation. And to also hit on last point, I think part of the experiment is also to give these new kind of congestion control rooms to evolve. And therefore we need some deployment of the queuing scheme in the network. So I think we're ready for that part.
Respond directly to that before we go to Cone?
I would. So did I understand this correctly, that the experiment is we're going to throw this in the network and see what happens? Because that's kind of what it sounded like.
Maybe Cone can speak to that.
Yeah.
I don't know.
Maybe the thing I want to say is the experiment is mainly for people to start working on the congestion controls, to get the real experience of what is going on, and to get engagement, because a lot of application developers, I guess, are interested in using this and want to see deployment, and also get convinced that deployment will happen before they really engage and solve all the problems. And what the problems we see today are mainly, well, the main problem is, of course, classic ECN fallback. And the longer we wait, the more classic ECN will be an alternative, because nobody starts to believe in whether LFRS will actually really happen. That's the main danger. And I don't think a lot of people are convinced that the problems in the current implementation cannot be solved. It's a huge opportunity to experiment and to gain better experience. In the beginning, we thought, okay, data center TCP would be the reference, and we didn't need to work on the congestion control. But in the meantime, this Prague has become a kind of reference implementation status, and now even asked to prove everything that it can gain. I think it's a wrong expectation, especially from the people working on that. If people are really concerned that there is no improvement possible, then okay, we should stop here or wait until this is really the case. But I don't have the impression that people are thinking in that way. People are waiting for deployment and really to get things running and see this. Also, what's important is we get a lot of traction in implementations. If you're going to wait, I think the confidence in this whole experiment and this whole topic will slowly disappear, which is a bigger danger to get progress than whatever concerns there are now, which are, I agree, minor or mainly performance improvement or performance issues with the congestion control itself. So I'm saying we should not wait, definitely not. And the experiment, it's still an experiment. We should engage, and more people will automatically work on it.
Okay. And then Jenna?
To Lars's question of what is the experiment, I think he is right in that we should articulate precisely what the experiment here is, and I think Kun answered some of the questions. I'll emphasize just 2 points in there. One of them is that our history has shown that just getting this deployed itself can be a simple experiment. What I mean by that is, even though it does, yes, you're right, Lars, that are we just going to throw this out there and see what happens? Getting something like LFRS, the ECN marking itself deployed is a pretty big experiment. If you succeed in that, then I'd be very happy. But yes, encouraging endpoints to experiment with different congestion controllers is also an additional piece there. But for them to do that, we need the bit out there in the network. So I would say that we launch the experiment to see if we can actually deploy this into the network. And once we do that, we know that we can build controllers, and we already have some example controllers that, even though they are not perfect, they'll do something with it, something pretty good with it. I would also ask a slightly different question, which is, do we think that by keeping it in committee, so to speak, or keeping it as a draft in the working group, we gain anything? If we don't gain anything by making it an experiment out there, my question would be, what do we gain by keeping it in the working group?
Yeah. I noticed that we lost Sebastian from the queue. If you want to jump back in, I think you were in the front at this point.
Thanks. So the concern I have at the moment is that the operational safety of all of the LFRS design and implementation over the wider internet has not been proven sufficiently. At the current time, speaking about deploying what we have seems rather premature. Without data showing that it really is safe over the long haul and not just over the short RTT, low hop count links between end user and CDNs, seems rather uncautious. I think LFRS simply isn't there that we should talk about a last call. Yeah? The data is missing. It's sad that after 7 years the data is still not there, but that's how it is. pretty sure that this data can be produced relatively quickly and presented, and if it's safe, no matter whether I like it or not, then make it an experiment. But if it's not safe, let's just drop them. But let's make this based on data and not just how we feel about this. I have a feeling in this discussion that many people have not actually looked in the detailed measurements that were presented. And hence we're discussing very much in the abstract while we should be actually talking about real data and numbers. Thanks.
I see Cone jumped back in. Maybe you want to address that comment before we go to Greg?
Yes, maybe the main problem that is open now, like if I see it, Sebastian, is the big round trip time, L4S competing with L4S itself. This is not. It's a concern, of course, and it's a performance concerns for L4S users themselves. It's a range where the congestion control that we have now is not optimal yet for the users themselves. A very simple fallback is just, okay, if your round trip time is bigger than a certain amount, we fall back to cubic, and the problem in itself for our reference congestion control is solved, and it could be used as a reference for experiments. And of course, it's better to work on improving for longer round trip times, also the performance for L4S. But on the other hand, what's the value of that? Because if you have a round trip time of 160 already, you're better off, or that extra 1 millisecond or 15 milliseconds is not going to make a big difference. So we should also see what is the relevance of the problems that we see today. In practice, I think they are zero. It's just a matter if there is interest for people with a very long round trip time to have a buffer of 1 millisecond instead of 15 milliseconds, it will be worked on. Otherwise, the congestion controls will automatically fall back. But all these things, that's experience that we need, people working on it, and the right people with the right incentives working on that and improving it. If everybody looks at us and expects that we are going to make this ultimate super perfect congestion control, then that's the wrong way of progressing. We will probably starve at the end from exhausting. I mean, let's engage, let other people get the opportunity to work on. I see only one main problem, which is not that big. It's the classic ECN detection. So, and the longer we wait, the more classic ECN will be the alternative. So I don't see any gain in waiting. Let's go forward. The question is the network part okay? Then we should go ahead. If the congestion control is okay, I think now, it's not perfect, but it can be improved. So why stopping? I would say go ahead, make sure we can, as fast as possible, go to work group last call, and the rest will follow.
Okay, thanks. I have Greg, then Gori, Lars, and Sebastian, and we have to be quick. There's only a couple minutes left.
Yeah, I just wanted to point out that the original definition of ECN is 20 years old, and so far sounds like the deployment of that in networks is 0% to some number of decimal points, whereas here we have networks that are very interested in deploying L4S ECN signaling, and it would be a shame if the IETF didn't take that opportunity to move this forward into an experiment and get all the benefits that we're expecting to see from L4S.
Okay, Gori.
Am I at the end? I'll wait to the end.
Okay, Lars.
Right. So I didn't want to sound, well, my audio is really garbled. I didn't want to sound like I was going to require like the perfect congestion controller for this experiment, right? But you know, asking for a fabric upgrade is a pretty tall ask, and not being able to motivate it to application developers that you also talked about, Connor, that, you know, no application can use this without there being a congestion controller that delivers some sort of benefits to that application. Right, so you can throw this in a network, but if it can't be exploited by the app, it's not going to be a very great deployment story, right? So we can argue whether what we currently have as a congestion controller is good enough, but I think this is an integral part of this experiment. If you think back, right, we've done a few classes of this before. So either we've done queuing improvements that intended to improve existing TCP traffic without TCP changes, right? We know how to do that. We've also done TCP changes to try to, you know, work better with whatever queues they found in the network, and we know how to do that. And then we've done ECN, right? We changed both, changed the network and changed TCP, and it was a pretty integrated design, right? It was pretty minimal, but it was integrated. And in my mind, this needs to be a similarly integrated activity. It's not enough to just to upgrade one part without at least some heavy thinking about how, you know, that queue change is gonna manifest itself in application level improvements. Otherwise, what's the incentive?
Okay, so I agree. It's very important to have both. And looking at the past, in the past we had the congestion control for ACN, which was very simple, just do the same as before instead of drop. And afterwards, we didn't see any or hardly any deployment in the network. Now it's the opposite. We have a network with a lot of interest, with a lot of plans to deploy, with standards already defined, people working on products, and now we're saying let's wait until the end host, which are usually the easiest one to change things, are at par. I think we are blocking this at the moment. We have good engagement in networks and plans to deploy. Let's release this. I don't see any, and unless well, I would like to ask other people as well. I don't see anything that cannot be solved in the host at the moment.
We're going to need to wrap this up in the next minute or two. The plenary is about to start.
But anyway, the short thing is we have something which is good, which can be used at the moment already, within a specific range, with some corner cases not. But if that's the question, we have that already. We can do the experiment. Applications can use it already within certain constraints defined in the operational guidelines.
Okay, I think the chairs need to take what's been said here under advisement. And we will consult with the AD about the path forward here. Gori, did you want to add anything to that? All right, any last words from anybody else?
I think Bob may want to wrap up his.
I don't necessarily want to wrap up the talk, but I just want to sort of state a fact that I believe that the people who are doing these network implementations would not deploy it unless there was an RFC out there. And you know, the process of going from working group call to that is still going to be a few months away, because that's how long the IETF takes. And these guys are ready, but they're not going to deploy it if there's not a you're not going to start dealing with a change to IP without the IETF approving it.
I think we're basically at time. Gori, did you want to have a last word?
I think it would be worthwhile taking a sense of those people left in the room. We know people have already left the meeting, so this can only be imprecise, but if you think that it would be a good idea to have a working group last call in the next period, can we get some indication about who would be against that and who would be for it?
I think we've lost so many
Wanna
people
do
for
a
the meeting at
poll
this
here?
point. I'm not
State
sure.
the question a bit more clearly.
Yeah.
Yeah.
How many people would commit to review this document and contribute to a working group last call if we were to start one before the next IETF? How many people would review? Okay, so we're collecting that via the tool, and it will again help the chairs to gradually make forward progress. We will be talking to our AD, we'll be talking to the document editors, and when does this poll conclude?
When you click on end session.
There we go, at that point here. 18 people said that they would review this if it was presented for a working group last call. But that's a good number. So that makes me happy that we will have reviewers when we come to that decision. Right, Meteco says we can have a little more time if it's necessary. Is there anything necessary?
Plenary starting now. I think we need to declare victory.
I'm happy with that. Bob's got additional slides that will be in the proceedings.
Yeah, I mean, they're basically saying what's in the draft. I can also post on the mailing list, which, well, I've already done that for the last set of deltas, but I can say what the main changes are that haven't been discussed on the mailing list.
Okay. Thank you. I'm done from my side. Thank you ever so much for a very productive meeting. The other chairs can say something when we're finished.
I think we're done. I'm going to tell Meteco that I think we're done. Going once. Okay, I think we're done. Thank you very much, everybody.